Hello everyone, welcome to my YouTube channel TechTalk with Rais. Today we are going to discuss a very important topic related to data access. So without wasting much time, let us move on to the next slide and today's topic. Here is today's topic, which is caching and caching techniques. In this session we are going to learn about caching and different caching patterns. Let us move on to our today's agenda. Today's agenda is why is caching required? What are the caching types in typical distributed system? Different caching techniques and patterns, advantages and disadvantages of different caching techniques. Let us move on to the next slide. Why is caching required? In a RAID heavy system, loading data from actual source of data can result into response slowness and thus increases system latency. At a very high level, it doesn't look to be an issue, but it results into very bad user experience for the service. Caching improves page load times. Also, it can reduce the load on backend servers and databases. In caching model, a temporary memory sits between server or client and actual source of data, which is databases. This way, the request dispatcher will first look up if the request has been made before and try to find the previous result to return in order to save the actual execution. This way, it gives us a lot of benefits. Some of them are listed here. For example, faster lookup, quick response, reduced load on the backend servers and databases, and reduced latency. Let us move on to the next slide. In this slide, let us try to understand the typical distributed system architecture. In a typical distributed system architecture, there are two parties, client side party and server side party. In client side, there is one client layer, and in server side, there are 3-4 server side layers. In client side, the client basically initiates the request from the client side, which can make use of forward proxy as well. At the server side, the first layer is basically API gateway layer. The second and third layer collectively makes an application layer, which is basically application layer and caching layer altogether makes a single layer, that is application layer. And finally, the third server side layer is basically storage layer. The storage layer is actually responsible for storing actual data. So this storage layer is basically the main source of actual data. This way we can understand that client has to make a request and request will go up to the end, and then finally it will retrieve the data and return back. So it looks like it will take a lot of time in returning data. So it is better the response from the last layer can be shaped at the individual layer to provide a faster response. This way, there are so many caching layers can be implemented, like a cache can be implemented the client layer also, a cache can be implemented the API gateway layer also, a cache can be implemented the application layer also, and also a cache can be implemented at the storage layer itself. So let us move on to the next slide. In this slide, we will discuss about different caching types in typical distributed system. Like we explained from the previous slide that at each layer we can perform caching for the faster response time. This way we can have a client side caching, a gateway layer caching, content delivery network caching, database caching, and application caching. Client side caching, if we talk about examples like browser caches and client side OS level caching are some examples. Gateway layer caching, basically a reverse proxy also acts as a web server caching, so it can also cache the some static or dynamic contents. CDNs, content delivery networks, are basically located at the different geolocations, which can also acts as a caching layer and can serve static or dynamic contents at the local geolocations. Database caching is basically different solutions are there like MySQL, PostgreSQL. They have some sort of settings in the configuration file which can help us to enable some level of caching. And finally, application caching. So application caching is one of the kind of most critical and very important topic. In this session going forward, we'll discuss about the application caching itself. Whatever patterns we will discuss, those are applicable mostly towards the application caching. The example whatever I'm giving in this session going forward will be mostly towards the application caching. Application caching is of two types: query caching and object caching. In query caching, basically whatever the query is made to the database from the application, that query is hashed and the hashed key is saved as a key, and the value will be the out whatever the response of that query is received. This will be saved in the cache memory, but this technique has lot of disadvantages. Like if the cache data is expired, in that case complex queries data in the database, it will become little hard to delete them. And object caching is something what we should be using. Like object caching, we should treat the whole data as an object. And let us move on to the next slide. In this slide we will discuss about different available caching techniques or patterns. At a very high level, there are four caching patterns. Number one, cache aside caching. Number two, write through caching. Number three is write back caching. Number four is refresh ahead caching. For optimized performance and best results, it is always suggested to use a combination of caching techniques. Let us learn all these caching techniques or patterns one by one. Let us move on to the next slide. Cache aside caching. This is pictorial representation of cache aside caching. Basically, let's say clients want to write something, or particularly let's say client want to read something. This particular cache aside caching is mostly helpful in the reading or retrieving the data, or kind of if the system is read heavy, this particular cache aside caching is mostly used. How it is used? Let's say client 1 initiates a request for the reading a particular data. The request is landed on the application server. The application server first look up the local cache or caching layer. The caching layer, let's say, doesn't have that particular data, that means cache miss happened. Then finally application servers directly calls to the database. If the data is there, that particular data will be returned back. Then application will save that particular data to the caching layer, and finally it will return to the client. Few things to note here, like first, this particular technique will be mostly used in the reading for the reading of the data. And one thing to note here is like caching layer is not directly interacting with the database. It is application who is responsible for reading or writing to the database and updating to the caching. So caching layer doesn't have any responsibility of updating to the database. There are some benefits and disadvantages of this particular technique. Let us see into the next slide. Here are some key points of cache aside caching. Like application is responsible for reading or writing from the database. Cache does not interact with the storage directly. Memcached is generally used in this manner. Like we have heard, like memcache and redis, these are some in-memory cache which basically improves our response time for the, let's say, these are mostly used in the read heavy systems. Also, cache aside technique is called lazy loading. Only requested data is cached, which avoids filling up the cache with data that isn't requested. Disadvantages: each miss result into 3 trips, which can cause a noticeable delay. Cache can return also stale data, so setting up a TTL is must. So last disadvantage what we are discussing, like cache can return stale data. Basically, let's say there is some fresh data available in the database, but the request is coming and it is returning from the cache itself, so that means it can return the stale data. So better is to provide a TTL to the data, so that after some time it gets expired and it can be kind of replaced with the fresh data. So let us move on to the next slide. Write through caching. This is the second type of caching technique. This is mostly used in the writing data. When client is going to write some particular data to the database, then this particular type of technique is used mostly. How it is used, let us see how the request traverse. Here in this case, the client sends the request, ultimately it lands at the application server. Applications reads and writes and reads the data from the caching layer itself. The application does not interact with the database directly, rather all the write and read are done from the caching layer itself. This way, this caching layer acts as a main storage, and whatever data is saved in the caching layer, this is asynchronously transferred to the database server. As the name suggests here, like whole data is write through, that means whole data will be written through the caching to the database. Here are the some key points and some disadvantages of this technology or techniques. Let us move on to the next slide. So these are key points, like application uses the cache as main memory, main data store, reading and writing data to it, while the cache is responsible for reading and writing to the database. A write through is overall slow due to write through operation, but subsequent reads of just written data are fast. Data in cache is not stale. This is one of the best or benefit over the cache side caching. In cache side caching, there were chances that data will become stale. Let's talk about disadvantages. When new cache node is added or due to some, let's say, failure or scaling, the new node will not cache entries until the entry is updated into the database. Cache side in conjunction with the write through can mitigate this issue. In the previous slides, I already told that we have to use these caching patterns or caching techniques in conjunction of each other, so that they can give the best performance and best results. The one more disadvantage of this technique is basically most data written might never be read. So for that, to minimize that, a TTL setting is must. Let us move on to the next slide. This is write-back-cahing. This is third caching pattern. Let us discuss about this. Basically, like the diagram or pictorial representation depicts, all the read and write will happen from the caching layer itself. That means, again in this case, application server is not going to interact directly with the database for reading and writing data. Rather, the reading and writing data will be from the main storage, where caching layer acts as a main storage. So let's see how the request traverse in this case. The client sends a write request. The write request is landed at the application server, and application server writes the data to the caching layer and also adds an event to the event queue. And there is an event processor which picks this event and asynchronously transfers this data to the actual data store, which is database. So if you can see from here, like whole operation after 4 is completely asynchronous, Application is only interacting with the caching layer, and remaining things are asynchronously being transferred to database using a event queue. So this is also called write behind technique or write behind pattern, caching pattern. There are some good benefits but some disadvantages also of this pattern. Let us see some key points and disadvantages of this pattern in the next slide. Let us move on to the next slide. So these are key points. This is also called write behind caching. In write back caching, the application performs add and update entry in the cache and asynchronously write entry to data store, improving write performance. There are some disadvantages, like there could be some data loss if the cache goes down before data is actually returned to the storage, which means database. So it is more complex to implement. This is also a disadvantage. Let us move on to the next slide. Refresh ahead caching. Like in the previous slides I told, like out of these 4 caching techniques we have to use a combination of caching techniques to provide best performance and optimized results. So this is like refresh ahead caching, one of the caching technique which will be used in the conjunction with the other caching techniques. In this particular technique, basically again whatever data is in the main storage in the caching layer, that needs to be refreshed time to time from the backend storage, which is basically database. So whatever data was written in this, let's say, caching layer, and some TTL must be set in this particular data. When this data is about to expire based on set TTL, at that time this data regularly refreshes itself from the backend database server, and thus this way the latest available uh, version of the data is served to the application server and finally ultimately to the client. So this way you can see like this particular data is regularly being refreshed, and this is why it is called a refresh ahead caching. This particular caching technique must be used with some particular already used caching patterns, for example write through or read through. Here are some key points and some disadvantages of this technique. So key point is like you can configure the cache to automatically refresh any recently accessed cache entry prior to its expiration. Refresh ahead can result into reduced latency versus read through if the cache can accurately predict which items are likely to be needed in the future. Disadvantage is basically not accurately predicting which item are likely to be needed in the future can result in the reduced performance without the refresh ahead. So this was all about the caching and different caching patterns. I have covered almost all the caching patterns and given examples as well, and tried to explore the distributed system architecture and different layers to give you insights of the different caching techniques and caching types.